In this lesson, we're going to begin by learning how to simplify expressions with exponents that are fractions. Okay, so here we have 27 to the 2/3, and we remember that the denominator of 3 means take the cubed root, and the numerator just means square. So we're going to start by taking the cubed root. So we'll start by taking the cubed root of 27, which is 3. And then I'm just copying over this exponent here, 2. We still have to square. 3 squared is equal to 9. All right, we're going to proceed the same way in the second example, and we're going to remember that this exponent applies to 27, not to the minus in front. So we're going to start by taking the cube root of 27 again, like above. And so we have 3 for the cube root of 27, and then we're going to square. Notice we only square the 3, not the minus, so this is equal to negative 9. All right, in number 3, we have a fraction, and we're going to begin with that denominator taking the square root of 25 over 4, so that will be 5 over 2. And now we're going to cube 5 over 2, and that would be 5 cubed is 125, and 2 cubed is 8. All right, in number 4, we have this negative fraction and a negative exponent. So we're going to start by taking the reciprocal of the fraction and making that exponent positive. So that would be minus 64 over 27. So there's the reciprocal. And notice I attached that negative to the 64. You could attach it to the 27 or to the 64. It doesn't really matter. Make the exponent positive now. Okay. And now let's start by taking cubed root. Cube root of minus 64, that's negative 4. The cube root of 27 is 3. And now we're going to square everything in parentheses. Now notice the minus is included in parentheses. So now the square does apply to that negative symbol. So we're squaring minus 4. That would be positive 16. And we're squaring 3. So that would be 16 over 9. In number 5, we're applying a negative exponent to 25. Again, this exponent applies only to 25, not to the negative symbol. So we have minus 25 to the negative 1/2. So first we're going to just take the reciprocal of 25. And change the negative 1/2 to a positive 1/2. So all right, so in the denominator, we're going to take the square root of 25. In number 6, we have an expression involving exponents raised to a fractional power. All right, so like before, we're going to first do the denominator, or the 5th root. So start by taking the 5th root of 32. All right, that's 2. Next, we'll do the 5th root of x to the 10th. So we take the 5th root by dividing 10 by 5. And we get 2, so that's x to the 2. Now the 5th root of y to the 15. Again, divide 15 by 5. And we have y cubed. All right, now we're going to square everything. 2 squared is 4. X squared squared is x to the 2 times 2, x to the 4th. And y cubed squared, y to the 3 times 2, y to the 6. In number 7, notice the minus 8 is in parentheses. So we're going to take the cube root of minus 8. We'll start with that. All right, again, we're doing the denominator first. Cube root of minus 8 is minus 2. The cube root of x to the 12, well, divide 12 by 3, we have 4, so that's x to the 4th. Cube root of y to the 21, divide 21 by 3, and we have 7, so that's y to the 7th. And now we're squaring, we're using this numerator. All right, we're going to square negative 2, and that would be positive 4. Square x to the 4th, multiply the exponents, and we have x to the 4 times 2, x to the 8. And then y to the 7th squared is y to the 7 times 2, y to the 14. In the next few problems, we're going to use the Pythagorean theorem to get some information about a right triangle. All right, so let's write down the Pythagorean theorem. First, let's just draw a picture of a right triangle. And these are the legs. We'll label them A and B. And we always label the hypotenuse with the letter C. The Pythagorean theorem says that we have the following relationship. A squared plus B squared is equal to C squared. All right, that's the Pythagorean theorem. All right, so in number 8, we're asked to find the hypotenuse of the right triangle with legs 9 and 12. So we have a right triangle. Legs 9 and 12, and we have to find the third side, the hypotenuse. So we're going to use this Pythagorean theorem. We're going to write down A and B are 9 and 12. So we'll write 9 squared plus 12 squared is equal to the hypotenuse squared. We're calling that x squared. All right, so let's just figure this out. This is 9 squared is 81. Okay. So we have 225 is equal to x squared. So x is the square root of 225. And we recognize that 225 is a perfect square. It's equal to 15 squared. So x is 15. So that would be C. That would be the hypotenuse. All right, now we want to find the third side of the right triangle with one leg of length 5 and a hypotenuse of length 8. All right, let me just show that over here. Okay, so again, let's just draw a picture. So one leg has length 5 and the hypotenuse has length 8. So put that as the long side next to the across from the right triangle, and this is the side that we want to find. So let's write out the Pythagorean theorem. 5 squared plus x squared is equal to 8 squared. Making sure to substitute 8 for C, because 8 is the hypotenuse opposite the right angle. So we have 25 plus x squared is equal to 64. And we're just going to subtract 25 from both sides. So we have x squared is equal to 39, and x is the square root of 39. In number 10, we're also going to use the Pythagorean theorem to see if the following 2, 5, and square root 29 are the lengths of the sides of a right triangle. Okay, so here are the various lengths, 2, 5, and the square root of 29. And we have to make sure, we want to see if the following relationship is satisfied. Okay, do the sides satisfy this? These three sides, do they satisfy this equation? We have to make sure that we substitute for C whichever is the longest side or the largest number. All right, so what about, well, obviously 5 is bigger than 2. And which is larger, 5 or the square root of 29? Well, 5 is the square root of 25, so the square root of 29 is larger, so this must be C. So we substitute 2 squared plus 5 squared, and is that equal to the square root of 29 squared? That's what we want to determine. All right, so that is 4 plus 9 equal to square root of 29 squared is 29. Sorry, not 4 plus 9. 5 squared is 25, so let's write that over here. Is 4 plus 25 equal to the square root of 29? And obviously it is. So that means that these are the lengths of the sides of a right triangle. So the answer is yes. Okay, number 11 concerns a rectangle. So we have a rectangle with sides of lengths 3 and 5. And we will want to find the area and the perimeter. Well, let's remember that the area is equal to length times width. So in this case, that would just be 5 times 3, or 15. Okay, now the perimeter is twice the length plus twice the width. So in this case, that would be 2 times 5 plus 2 times 3. So that's 10 plus 6, or 16. Now let's just imagine we had put units here. All right, so let's say this is 3, let's just say this is inches. 3 inches, 5 inches. Then the area 15 would be square inches, or sometimes you write it like this, inches squared. And the length would simply be in inches. That is, the perimeter would simply be in inches, because it's a type of length. So it's a one-dimensional unit. Number 12 is about a circle, and this one says a circle has diameter 12. Now be careful to read this properly, or read it carefully. Sometimes we're given the radius, and sometimes we're given the diameter. This time we're given the diameter. Diameter consists of 2 radii. So here we have a diameter of length 12. That means the radius is of length 6. So the radius is 6. Okay, so we want to find the area and the circumference. Well, the area is equal to pi r squared. So that would be pi times 6 squared, or 36 pi for area. And circumference is equal to 2 pi r. So that would be 2 pi times 6, which is 12 pi.